Intro to arc measure. Arc measure. So it's the measurement that the arc makes around the center of the circle and measured in degrees. Example 1. Find the arc measure of the arc of AB and the arc of ADB in the circle C. So we kind of just show that this is like the circle with the center, right? That shows us C. So we just kind of do this circle with a dot in it that has the center. And then we do the letter that's in this, that represents the center. So when we talk about arc measure of these arcs, so we have two different ones, right? We have the measurement of the arc of AB. So it's going to be this one, right? Like, what's this arc measure? And then the other one is ADB. So it's still AB. We're still looking at the arc measure of what is formed from AB, but we're going to go through the point D. So that's kind of the more important part, is to understand kind of our major arc and our minor arc. So it kind of depends, and I'll indicate it by if there's another point in it, then it's going to show you need to go the long route. So here we go, and let's find the arc measures of both. So if we have this one, well, this one's actually pretty straightforward because it's kind of given to us right here. So this arc measure is, right, it's measured in degrees, and it's measured around the center of the circle. So right here it tells us it's 102 degrees. So that's our answer. Now let's look at it from this side, right? So if we have a circle, right, circles or anything that goes right fully or all around, it's measured in 360 degrees. So the other measurement that we would find would just be 360 minus 102, right? And that would give us the arc measure. So let's get our calculators out. So if we go 360 minus 102, we get 258 degrees. So this would be, right, the arc measure of this right here. And so there we have our first example. Now let's go ahead and do the second example. Example 2, find the arc measure for the following. So we have DE, so we have this right here that we're looking for, and we also have EF, which is right here. So if we're looking for these in this circle, right, in the circle A, and then we need to know that BE is the diameter. So that's important. So this is the diameter. Now, why is that important? Well, if you take a circle, right, which is 360 degrees all around, if you cut that into half, then we're saying the top part is 180 degrees, and we're saying the bottom is 180 degrees, because 360 divided by 2 is 180. So now that we have that information, so now let's find the measure, the arc measure of, right, this DE. So we're looking at that arc DE right here. So we know a couple things. We don't really know what it is yet because there is no numbers that it just gives us. It's not an easy one. But we do know that a straight line like this is going to be right like 180 degrees. So if we add up the three arc measures, that's going to be equal to 180 degrees. But we do know a couple. So we do know that this one right here, CB or BC, right, this arc measure is going to be 52 degrees. We know DC is 90 degrees. So anytime you see this square, right, a square like this, it indicates 90 degrees. So this DC is 90. So as we know now, three measurements, right? We know 180, and we know these two measurements. We can actually solve for the one that we need to solve for. So let's go ahead and fill this in. So when we see this for the arc measure for the DC, right, that's going to be 90 degrees plus, and then the BC or CB, right, we just mixed them up. You gotta put CB here. Let's go ahead and write that. So it's consistent. So this is 52 degrees, and this stays the same as 180 degrees. And then we're left with our unknown, and we just need to go ahead and solve. So the first step is we're going to add these two together. So that is going to be 142 degrees. Then we have 180 on the right-hand side of the equal sign. And then to find our unknown, right, we just need to get rid of the number on the left. So how we do that, right, we're going to subtract the 142 on both sides. Because then this becomes 0, which is what we want, and whenever we do one side, we have to do the other to make it so that it still stays equal. So we have 180 minus 142. So another quick way to think about this is we can go 180, right, in our heads, minus 140, so that would just give us 40. But notice we have 142. So if we just go ahead and just subtract 2, we get 38. So it's just another way to think about it in terms of subtraction. That kind of shows you how math can be flexible, and that's how kind of people do math in their heads. It's just they create numbers to be like, instead of 142, they go 140, and then they just subtract the next 2. So what's our measurement that we're looking for? Well, it's 38 degrees then. That's our answer for this one. But if we go back to our problem, we actually have to find 2. So we found 1. Now we need to find, right, arc measure for EF. So this one right here. So once again, we know a straight line makes 180 degrees. So if we have 180 degrees is on one side, and we're looking for EF, right, that arc measure, and we have what's given to us here is 60. So rather than just saying FB, right, all of them have to add up. So this is 60 degrees, this is 180. Now we just need to go ahead and subtract 60 on both sides, and we get the arc measure that we're looking for, which is 180 minus 60, and that gives us 120 degrees. And that would be the second one that we needed to find.